Lesson 82, we're graphing the sine and cosine functions. This is a rather complex lesson, so if you were gone that Friday of it, this would be a very good lesson to get caught up with. We're going to start with a little review. Let's start with our sine function. Sine of theta is always equal to which variable again? Well, it's equal to the y value. Also, if we look at cosine of theta is always going to be equal to the x. We've been teaching that day one. The fact that the sine is always going to be equal to y and the cosine is always equal to the x is going to play a vital role as to how we go about graphing these. So if we start with our sine function, we start with our unit circle. We're always going to start over here on the x-axis at angle 0. Okay? Now once again, if we work with the sine function, understand sine of theta is equal to y. So what we really want to look at is as we move this point around the unit circle, we want to see how does that affect the y value. And as we talk about the y value, we mean the y value of that right triangle as we move that point around. So let's back up a little bit. If we start at this angle 0 on the x-axis, notice if I draw in a really small right triangle, notice the value of that y value, that vertical distance, is very, very close to 0. And in fact, when we start out, it is 0. Okay, there's no triangle that exists. But now as I move this point up around the circle, notice my y value here is getting a little bit bigger every time. That's why as we approach pi over 2, here's pi over 2 on our x-axis. Notice our y value is approaching 1 up here. That's why when we go from 0 to pi over 2, it's approaching 1. Now let's go to the left-hand side of it. Let's go from pi over 2 to pi. Notice as we go down, our y values are getting smaller and smaller to the point where they're eventually going to get down to 0. So if we go over here to the graph, we go from 1, and as we approach pi, we're going down to 0. Okay, if we draw in these same right triangles, notice that vertical distance. Notice it's approaching -1 now. That's why from pi to 3 pi over 2, we're going from 0 to -1, and it's for the same reason as we move back up to 0. That y value is getting smaller and smaller. Or actually, it's getting bigger, but it's getting closer to 0. And again, if we repeat the process, if we continue to go around the circle, this wave, it'll repeat. And this is really the foundation as to why the sine of x is going to look like the following. Again, notice our x-axes, pi over 2, pi, 3 pi over 2, and 2 pi. We're always going to use radians when we graph sine and cosine. Let's go ahead and take a look at the cosine function. I'll go a little bit quicker with this. Cosine of theta is always going to be equal to x. Again, if we look at these right triangles, I don't care for the way the book demonstrates these triangles. If we look at our regular triangles that we're used to, notice that x-axis here is right on the x-axis. And notice when we start over here at 0, at the origin, we're actually at 1. Okay, this is a really long distance right here. It's length 1. And that's why for the cosine function, we're always going to start at 1 or -1. Now, as these triangles move up closer to -1, notice this distance right here. I'll go in red. Notice this distance here. Our x value is getting smaller and smaller. If I draw one that's really close to going straight up and down, notice that's even smaller yet, now in green. So as we approach pi over 2, I'll go ahead and put it on the scale again. This is pi over 2 straight up. Notice we are approaching 0, and that's why we go from 1 and we're going down. Again, it's the influence of x as we move this point around the circle. As I go from pi over 2 to pi, and we look at our x values, notice the x values are getting bigger in a sense that they're going to -1. So in a sense, they're going to -1. They're actually getting smaller. So that's why we go down from pi over 2 to pi. If we look at our x values as we go from pi to 3 pi over 2, there's the first one, there's the second one. Again, the x value is what we're concerned with. We are once again approaching 0. And as we go from 3 pi over 2 to 2 pi, they're working their way back up to 1. And once again, this wave is going to repeat. So in about 5 to 10 minutes, that's the explanation for how we come up with these functions. The biggest thing I want you to take away from this is when we are talking about the sine function, they always start at the origin. And if we talk about the cosine function, they're always going to start at our max or min, is what we want to call them. Start at. In this particular example, we start up here at the max because, again, that's, well, our a value was positive, and we'll get into that later on. Properties that go along with the sine and cosine functions, a couple of things that we need to take away. Number one is the fact that the amplitude is always going to be the absolute value of a. Notice our notation for sine and cosine. Y is equal to a times the sine of bx, and y is equal to a times the cosine of b. It's really important that you can be able to identify your a as well as your b. And as we move on, you'll catch on to those very quickly. Okay? The other thing that we need to know is that the period can be found by using this formula, 2 pi over b. So let's go through example 1. You'll catch on to the amplitude and period very quickly. It says to use the graph of y is equal to 3 sine of 4x to find the amplitude as well as the period. If we start with the amplitude, per the properties again, it says that it's the absolute value of a. Well, what is our a value for this particular example? Well, if we use our notation again, y is equal to a times the sine of bx. 3 is playing the role of a, 4 is playing the role of b. Therefore, we're really looking at the absolute value of 3, which is ultimately 3. Let's take a minute to look at the graph here. Notice our wave over here on the right. Notice its max is 3, and its min is -3. So when we talk about amplitude, it's really the height of the wave in terms of what the max and the min are. If we find the period, period can be found by using 2 pi over b. There it was right there. 2 pi over b, we need to identify the b value. B value is this 4. 2 pi over 4, which means pi over 2. So we found the amplitude to be 3, and we found the period to be pi over 2. That's going to be your first 2 steps when it comes to graphing these things. Speaking of which, let's go ahead and graph y is equal to 3 times the sine of 1/2 x. There's 4 steps that we need to use when we graph these. Step number 1 is going to be finding the amplitude. To find the amplitude, once again, it's the absolute value of the a value. A value in this case is 3, therefore the amplitude is 3. Step 2, we need to find the period. Period can be found by taking 2 pi over b. B in this case is 1/2. Multiply by the reciprocal. 2 pi over 1 times 2 over 1. We find that the period is 4 pi. If at any point I'm going too fast, just pause the video and then get caught up with your notes. Step 3, we need to divide the period into force. Divide into force. We start with what we found, or we actually start at 0, and then we end with whatever our period is. In this case, our period happened to be 4 pi. So there's our beginning and ending, so to speak, of what I want for the graph. And then we ask the question, if we want to divide it into force, well, what's halfway between 0 and 4? Well, it's 2 pi. Halfway between 0 and 2 is 1, therefore 1 pi. Halfway between 2 and 4 is 3, therefore 3 pi. Last thing we need to find is our pattern. Okay, if we go back to our function, notice we are working with the sine function right there. And if we go back to the very beginning, I told you to make note the sine function always starts at the origin. Here it was. Okay, so we're always going to start at the origin. So therefore our y value is always going to be 0 for the sine. So we're going to start at 0. And now the next question we have to ask ourselves, is this wave going to go up from 0 or is it going to go down from 0? Well, to answer that question, we need to look at our a value. A value in this case is a positive 3. Because it's positive, we're going to go up to the max. If it was a negative 3, we would go down to the min. So we're going to go from 0 to our max. Now that we hit our max, we're going to go back down to 0. And then we're going to go to our min. And then we'll go to 0. And believe it or not, this is all the essential information that we need to go ahead and graph this thing. I'm going to scoot this over 4 pi right there. We start with our amplitude is 3. So 1, 2, 3. 1, 2, 3. So negative 3. And then we want to create our x scale. Now I'm going to skip a couple of spaces to spread this thing out a little bit. Once again, we divided it into 4s. We start at 0. We ended at 4 pi. In the middle was 2 pi, and if you wanted to, you could throw in pi as well as 3 pi, but I'm going to keep it out of there just for to keep it a little cleaner. So this step 3, that actually determined our scale for us. And now in step 4 is where we're going to plot our 5 points. Now again, when we started with our pattern, we said we need to start at 0. So we start at the origin here. The next point then on our scale is going to go to the max. So we're going to go up there to 3. The next thing we said was 0. So we're going to go back down to 0 for the next one. Then we're going to go to our min. There it is, and then we're going to go back to 0. And in terms of the graph, this is all that I need to see. Well, not all of it, but I have my 5 points. I have my scale on the x-axis. I have my scale on the y-axis. Last thing that we need to do is just connect these points. Try to draw it to the best of your ability. And there's the graph of our function. I'm going to go through one more, and I'm going to go rather quickly. So again, pause it if you need to. Graph y is equal to 4 times the cosine of 2x. Step 1 was, again, the amplitude. Amplitude for this thing was 4. Absolute value of 4, so 4. Step 2, period. How do we find the period? Well, it's 2 pi over b. B in this case is 2. Divide by 2. So my period is pi. Step 3, we need to take our period and divide it into 4s. So we start at 0. We go to pi. We need to find everything else in between. Well, halfway between 0 and 1 is a half. Therefore, half pi. Halfway between 0 and a half is 1/4. Therefore, 1/4 pi. And halfway between a half and 1 is 3/4. Therefore, 3/4 pi. If the pi's confuse you, just throw the pi's out of it and see that it's 1/4, 1/2, 3/4, and 1 pi. If you just look at the fractions themselves without the pi's, that might be a little bit easier for you to see. Last thing is step 4, the pattern that we need to use. Once again, we're working with cosine, so if we go back to the beginning, we say we start at the max or the min. Therefore, determining the max or the min, once again we need to look at the a value. A value here is 4. And notice it's a positive 4. Therefore, if it's a positive 4, we're going to start at the max. Note, if it was negative 4, we would start at the min, then go to the 0. But because it's positive, we start at the max, we go to 0. Then we go down to our min. Then we go to 0. Then we end up back at our max. And that's how we're going to produce our wave. Real quick, our scale, amplitude is 4. There's positive 4. There's negative 4. Skip a little bit in between, again, to clean it up a little bit. This is pi. This is pi over 2. And once again, for our points, pattern that tells us we need to start at our max, which is 4, go to 0, go down to our min, go back to 0, back to our max. And there's our graph of cosine. Okay, 2 really good examples to work with. I would encourage you to try some of those practice problems that you see down below, A, B, C, and D. In particular, let's look at a C and D. Okay, give you a couple of minutes to try C and D, and once you have it, you can go to pause the video, and once you come up with the answers, unpause it, and eventually I'll have the answers on the next page.
Good afternoon. The following are your afternoon